Bismillahirrahmanirrahim. Dear students, I am Ahmed Mumtaz Mustahsan, your teacher for CSC 141 Introduction to Computer Programming. Students, we had a few hands-on sessions before, and today I would like to spend some time also in demonstrating the examples that we have used during my lecture, as well as some very interesting and good examples given in your reference book, How to Program C by Detail in Detail. So I have downloaded these examples from the official websites of Detail in Detail, and I will use the code to demonstrate it in the Visual C environment, and would like to discuss different aspects so that you can have a very good revision, as well as the concepts revision that we have already studied. So I'll be using the topic. We have done some hands-on exercises on arrays, but mostly I used one dimension or single dimension array. There was a topic that I could not complete in the last demo, and that was a multi-dimension array. So I'll start with the example of a multi-dimension array, and then we will have some practice of pointers, and then pointers and strings. So I have already created this file so that we could save some time in the typing. Okay, so we can always start with this Visual Studio, and you may like to start with a new project, or you can just use the last demo 2 project that we practiced in the last session. So what I can do, I can just move this back to this resource, and you remember we need to update it here, that exclude from building. What happens if I just keep it? That you will have two, basically you will have two main, and that will not allow you to link the file. So I have excluded it so that I can now create a new file, and you know that we can create a new file by add new item, and then we can select C++, and we can go back and see the, okay, it's a pointer operators. So I'll pick up the example. I think the example of the 2-dimension array, I think I'll come back it on later on. So it's a pointer operator, so I can give it a name as P pointer operator. I see, it's better you use lower key, P pointer. Since C is a language where we prefer to work in the lowercase, so I would like to have the name is in the lowercase. Okay, so I've got this file here, this environment here. Now I will pick up this code that already typed in, copy this code, and place it in this particular environment. Okay, so this is the example taken from the book, so I've just kept the reference so that you would like to see it in the book. And the book, it's a reference book, and the reference book is How to Program C by Detail. Okay, so here we have defined an integer variable a, and we have defined a pointer aptr, and we can define this is a pointer to an integer. Aptr is a pointer to an integer, and we have initialized a with 7, and then we have loaded the address of the a into the pointer. Then which is just a message. This is something new for you. You can use %p. It will display the address in hexadecimal, but if you use u, the same address would also be displayed in the decimal value. So it should work. It is just a message here. Here we are putting the output. This is the address of a variable a, and this is the address of the pointer. So it will not show the content, because with a we are using this ampersand sign, that means the address, and this aptr is also the address. So in the next print statement, we would like to print the contents. We can directly print a, and we can also use the pointer to print the data, and that we can use the static. So we put a static to pick up the data that is placed at location A. And why it will point to the A? Because we have loaded the address of A into aptr. Okay, and once again we can just show the address also. Here there is a very interesting combination, this ampersand and static. We can use it in any order. We can put address operator, ampersand sign, and a pointer operator, which is static, or we can put it pointer first and then the ampersand sign. So you know that it will not stay in this output will not stay here. So for that we use system pause, and for this purpose we need to include what? Include IO stream. Okay, so you can see that there is no red line here. So let's compile it. We can compile by build, compile and build. So it is successful. We can run through this without debug, and you can see the answer here. So we can see the answer in the first two statements. This is the address P and for address A, and this is the for aptr. Then the data that we have placed it from here, and this percentage ke baad, since we have used \n, so that's why this there is a \n between this percentage d and this percentage d. So the value of A is 7, and value of A using pointer is again 7. And then here we have just demonstrated this, and this we can see again that it will print the address, and you can see that the address has been printed in hexadecimal. How can you confirm that? You can confirm from here that this F is a hexadecimal digit, and rest you will, since they lie also common to the decimal as well as hexadecimal. Okay, so we have done that. Just to quickly go through it again, here I would like to use U, and I will keep it here, this one, just to show you that it also works, but it will give you an output in decimal. So Control F7 to build and Control F5 to run. So you can see that this output is in decimal because we have used %u here, and this output is %p, so it is in hexadecimal. Okay, so this was a very quick revision of the pointers, that how can we use pointers in the C++ environment. So if you want to just keep it, you can just move it back into the resource, and don't forget to exclude it for the next time. Exclude from the project property, and exclude from build. Yes, we will. Yes, exclude from build. Apply. Okay. In this way, you can always keep the previous programs that you have exercised, so that at the time of revision you can have a quick access to this data. So let us see what do we have in the next example. The next example, I would not like to go there. It's just passing of argument by value, and we this example we are passing, this is a function cube by value, and we are passing n as a value. But I would like to demonstrate that instead of passing this in this next example, passing by reference. The same program, here it is done by passing by value. We are passing it to integer n. So you are passing the value of number n here, and the function is using it. But in this particular example, a quick revision to have passing by reference. So once again I copy this. I'll explain this program when I copy it into the environment here. So it is the exercise pass by reference. So I paste it. This is the function prototype. You remember, you can provide the definition here, but if you want to provide the definition down, then what you can do, you can just provide the prototype, function prototype here. And here the function prototype says that nptr is a pointer to an integer, and we will use a pointer to pass on the argument. Here, since we are using a pointer, so what we can do is that when we call the function, we are passing the address of this number through this ampersand sign. And you remember what will happen, that the address of this particular variable will be passed on to this function. What does it mean? That whatever changes, if any, you have done it in the function, the same will be reflected in the main also. But here we are not making any change, rather in this is the definition, function definition. That was prototype, and here is a definition, and it's a cube. So you know that we can pick up the content by putting a pointer here, and then we can just use the variable nptr. So we are using content of the location pointed out by nptr, okay, and we multiply it by 3 times. You can see that there are 2 statics. This static is for the multiplication, and this static is for the pointer. This static is for the multiplication, and this static is for the pointer. So don't confuse by looking at 2 statics putting up together, and it works automatically. Okay. So once again, in order to stay, we would like to retain here इसकी आपको अच्छी प्रैक्टिस हो जाएगी, because we will be doing it again and again. And here what I would like to do, that I will, in the next exercise I will copy this. So let us see, next time I would like to save some time. Include IO string. Okay, it works. So we compile it again, control F7. Okay, it's not allowing that. Maybe what's wrong that? Let me see. Cube reference identifier not found. Cube by reference. So let us see. This is an error. We had a void, and since this is an error, so okay. And also now this was the error. Okay, it's good that we could find few errors and then we can just resolve it. Let's try it again. Control F7. Okay, this time it works. So आपने देखा what was the error? कि we have just combined it together like this. So since it become one single sentence, so that's why the system could not recognize the reference, means this variable was unreferenced there because it was connected with void. So we can now run it again, Control F5. So it's very simple. The value of 5 has been passed on, and now it's the pointer are used here, and these pointers has returned this one, and it's not returning. That's very interesting. Yes, it's not returning the data, okay, because it's just using the same NPTR, and this NPTR is equal to 3 times NPTR. So although this is a void function, but yet you are passing the result back to the main, and in the main program you see that you have got the result in the number. You got the result in the number, and then you have printed the value of the number here. So without returning, you have returned the value, and that is the beauty, and that is the advantage of using the pointers. Good. So this time I will just like to add new program here, add new item C, and the name of the example is convert string to upper. Okay, this is the example of converting a string to upper. So I would like to use P string to upper. Okay, we add that, and I've just kept it because I just like to save a little bit time here by copying this. Let me copy also this. Okay, first of all I would like to copy this. And then I will like to copy for the time being, place it here. Later on I will move it down. So just go back and bring this example that convert string to upper. I will explain you once I copy, then I can just place it here. Let me organize it at the top, and just would like to put it here, and also just like to before I end main. Okay, we can again correct it. We can find the same problem here. Somehow the space is skipped when we copy. So this is the space. I can just put void. Okay. No, seems to be okay. So just quickly go through it. This is the prototype definition of a function. This is the example of the string function, and we would like to use this function, but this is the user defined function. Since it is a user defined function, we are defining this function, so we are not including the system library here, anything. So convert to upper is our function, and we are using a pointer here to pass on the characters, the pointer to a character to this string, and that to this function, and this function will convert the string into the upper. So this main program, we have defined and initialized a string, so with the help of an array, or you can say that it could also be used as a pointer, because we know that the name of the array is the address of the array, and that could be used as a pointer. Okay, and then we can just initialize any string that we want, and we would like to convert it. This particular string has got some characters in lowercase and some characters in uppercase, but what we would like to do is to convert each and every character into the uppercase, which is a convertible character, not 32.98. so that we would like to see. So we will print the result, this same string without conversion, then we will call the function, and then we pass this argument. This array name of the array has been passed as a pointer, as an address to the calling function. The calling function will convert it and put the result back into this string, and then we can just output this string. So how this calling function is working? Calling function basically using toUpper, this function. Okay, this is a system function, but what we are doing that we are scanning the string one by one until we reach to the null character, and then we convert it into the upper, and then this is plus SPTR. This is something very important that you should remember. This is a string constant, but we have received this string constant here in a string variable. Although the data is there, the location is the same, but the name for this string we are using this pointer to a string to receive the address which was there in the string. It is just right, you write down SPTR is equal to string. So basically you are just receiving the data into a separate variable. Otherwise the memory location that holds the data remains the same. Okay, so that's why, since now this is a pointer variable, and we know that if we are using a pointer as a pointer variable, then we can update it. Now this pointer is running through this particular sequence of elements which are stored in this array. This is very important concept, students. Please try to understand that this is an array and we are using a pointer to pick up each and every element of the array, and that we are doing it here. We are scanning it from left to right by SPTR because it contains the name of the array is the address of the array. It is the address of the first element of the array. So we are starting with the first element and then we are gradually moving forward. We convert it, put it back because it is still the first address, then we move this pointer to the next. Then we just again convert it, and now since the pointer has moved to the second location, so the converted address will go to this one. So convert to uppercase, make pointer point to the next character. In this way this function works. So have we compiled it? I don't think so. So let us compile this. Control F7. Okay, we just need to cancel it. Just first of all we just move it up here, and I'm just doing it again and again just because that you should save whatever we are doing. Okay, so now we are here, and at this particular time we can just build it again. Do you want to reserve this file as a Unicode? No, we don't want to reserve this file as a Unicode. So pointer to string demo2 error 29 syntax error, and where is that syntax error? Let us see. We need to find out this syntax error. Unrecognized token. So we have made some mistake somewhere here. So we'd like to see where we have made the pointer string to upper. So this means that we might have made a mistake here. Line number 29. Let me see line number 29, 25, 26, 27, 28. Okay, so there was some non-printable characters. That's why I was unable to took too much time to find out the error. So we have removed that. Now it should work. And Control F5. Now you can see that this input string has been converted into the output string like this. Okay, so it happens when you copy the data from other file and paste it there. So although we could not find something here, but there were some non-printable characters over there. So as soon as I removed that, the error was gone. So let's see what next we have. Next is an example of print string through a pointer. Now this time, previous example, we have printed an array through a pointer. This time we will be printing a string with the help of a pointer. So I'll make the provision here first, move it up. Print string through pointer. File and let us see. We can copy this example. It's a bit risky, so I will just stop here so that some non-printable characters may not be obtained here. Okay, so let us correct this. Void okay. This is the prototype declaration, but for that purpose, let me first add we can add the file here. Then print characters. This one, this means that this prototype has not been done yet. It is okay. Now, why we are getting this? This we need to type again. Seems to be okay. Const character static SPTR. A non-constant pointer to a constant data. Okay, students, let me explain now that this is a function, print characters, and here we are using a const. Okay. Okay, so this is a constant character, means this is basically the data that is we would like the system to do not change this data. So we have used const character static ptr. इसका मतलब ये हुआ कि ये जो data हम इसको pass on करेंगे, that data is a constant data. The system is not supposed to change this particular data. Okay, and let us see here. It seems to be okay now. So after removing these errors which are unnecessarily induced due to this cut and paste time, but still I think we can save some time by copying the data from that file to here. Okay, so I quickly go through it. We initialize an array with this string, then use this putS function. This putS function we have studied in the class, in the lecture, and you can use it to display the result onto the output. Then print characters, you call this function. This function basically will print this character, okay, and then this is just to pause. Here the function receives the data and loop through this. No initialization. Why no initialization? Because we are receiving the data in static SPTR, this one. So there is no initialization in the for loop. Then we can move through this pointer constant and then it should print the result. This particular example is very important because after that I would like to explain this particular concept of const character and character const static PTR. यानी कि दो चीज़ें मैं आपको explain करना चाहता हूँ कि एक when we declare a data constant और number two when we declare a pointer constant. So first of all just see the demo. Control F7, Control F5. Main already exists. ये हम भूल जाते हैं. We need to do that. Yes, apply. Okay. Good. Control F7. Control F7, it's okay. Control F5, so it's work. Print character of a string. Bizarre, this seems to be a very simple program, but the important point is that just concentrate here that this is a constant character static SPTR. This means that this character pointer to the character that you are declaring to access the data. This data is a constant data. If a system tries to modify this data in this function, then the system will display an error message. And how it will display an error message? For that, I will bring another example. This time I will be using the same environment. I will just copy the next example here. This is pointer error. So this, although this program will not work, but just this is important to demonstrate it there. So I copy it and then I would like to paste it here. Okay, this is just the, since it has error, so I don't need to run it, but just like to show it here to you. This is a prototype declaration, and this prototype declaration, first of all here, that incomplete type is not allowed. What does it mean? This is a const int, so let me correct it first, the error here, then const int, ये हम कॉपी करते हैं तो उसमें ये प्रॉब्लम आ जाती है. Okay, so this is basically the same example that we have done before. Here this is a const integer, pointer to an integer which is a constant, means you cannot change that. But here we have defined integer y, which is an integer, and then f attempts an illegal modification. We pass this address to this function f, and this function f, which also says that const integer static xptr. So this is a pointer to this integer, and what it's doing that here, expression must be a modifiable value. Since it is a constant, एंड किस चीज़ का कांस्टेंट है? दिस इज अ पॉइंटर टू अ कांस्टेंट डेटा, पॉइंटर टू एन इंटीजर विच इज कांस्टेंट. अब ये पॉइंटर टू एन इंटीजर विच इज कांस्टेंट, और यहाँ पे इंट y इज इक्वल टू, आप यहाँ पे कोई वैल्यू भी दे सकते हैं, y इज इक्वल टू 10, and then you pass this address of y to this particular function, and this function is trying to modify it, and it is not supposed to modify, so it will generate an error message. Okay, अब अगर आप इसको यहीं पे आपको it's showing the syntax error, but just for the sake, if you just want to compile it, so first of all let me close this output window, and then I can just build again. Okay, you cannot assign to a variable that is constant. ये precisely message था that I wanted to show कि xptr is a pointer to an integer which is attempting to modify the value of y which was 10. तो इसमें आपको ये मैसेज दे रहा है कि you cannot assign to a variable that is constant, क्योंकि this 100 that you are putting it up here, basically you are putting it up somewhere here. So अगर आपको ये कॉन्सेप्ट समझ में आ गया है तो इसका मतलब है कि आपको पॉइंटर समझ में आ गए. आई एम रिपीटिंग इट अगेन. ये एक कॉन्स्ट इंटीजर स्टैटिक पीटीआर, ये क्या चीज है? इंटीजर स्टैटिक पीटीआर इज ए पॉइंटर टू एन इंटीजर. दिस पॉइंटर टू एन इंटीजर विच इज कांस्टेंट. क्या चीज कांस्टेंट है यहाँ पर? ये इंटीजर डेटा कांस्टेंट है, और ये इंटीजर डेटा हमने यहाँ पर डिफाइन किया इंटीजर y इज इक्वल टू 10. अब हम क्योंकि इस फंक्शन को पास ऑन करने जा रहे हैं, तो हमने इस फंक्शन को इसका जब एड्रेस पास ऑन किया तो यहाँ पर क्योंकि वी हैव डिक्लेयर्ड कि ये कांस्टेंट है, तो आप इसको चेंज नहीं कर सकते. देयरफॉर जब इसको इसने रिसीव किया यहाँ पे विच इज xptr विच इज पॉइंटर टू एन इंटीजर विच इज कांस्टेंट, एंड नाउ दिस पॉइंटर इज अटेम्प्टिंग to modify the value of y sorry, which is an integer constant, so it gives you an error message. Okay, now I show you another example. I hope कि ये आपको समझ में आ गया. तो let us pick up another example here. I would like to keep it also. So what I can do, add and this time it is, that's I say combined with the previous one. This is pointer error, and pointer error number 2. So I just give pointer error. Okay, so this is a pointer error, so let me copy, copy it and paste it here. Have we copied it completely? Yes, I think so. So what do we have here? Up we are extending the same concept, integer x, integer y, and here we have declared integer static const ptr address of x. What we are doing here, the difference, this is a pointer constant to an integer. Okay, this is basically integer is not constant, but the pointer to an integer is a constant. Last time इसमें और previous में क्या फर्क था? इसमें देखिए कि constant was here, before integer, constant was before integer. अब ये constant integer और pointer के दरमियान में है. ओके ये देखिए, this constant is in between integer and this pointer. So pointer is a constant pointer to an integer that can be modified through pointer, but pointer always points to the same location. ये इंटीजर मॉडिफाई हो सकता है, इंटीजर को आप मॉडिफाई कर सकते हैं. मींस कि आप यहाँ पर देखें कि इंटीजर, ये इसके कंटेंट्स हैं ptr विच इज पॉइंटिंग बेसिकली टू x. सो इसको आप मॉडिफाई कर सकते हैं. अगर आप यहाँ पर चाहें तो आप इसको, आई कैन शो यू another example. Static ptr is equal to 100. It will not display any error message here like this. Integer static constant ptr expression must be modifiable. लेकिन when we try to load the address, हमने इसमें पहले एड्रेस लोड किया था x का, तो इट वॉज अ पॉइंटर कांस्टेंट विच वॉज पॉइंटिंग टू x. अब हम इसी पॉइंटर को यूज करना चाह रहे हैं टू लोड द एड्रेस ऑफ y, सो इट विल नॉट अलाउ अस. हाँ, इफ आई जस्ट रिमूव दिस, देन आप देखें दिस एरर मैसेज हैज गॉन. क्यों? क्योंकि नाउ दिस इज पॉइंटर टू एन इंटीजर. This is just a pointer to an integer. Okay? Up, you can just change it that this is a pointer variable. But when we used static const ptr, इसका मतलब है कि this is an integer static const pointer, means कि pointer cannot be changed. Okay? तो दोनों का डिफरेंस समझ में आया? In this case, agar if just I remove that, I think I have just demonstrated that. If I remove it, then you can see that this ptr is basically is now allowed to pick up the address of any particular variable. So coming back to the next example. Now this time we'll make a double fault, attempting to modify a const pointer to a constant data. So हमने separately तो we have seen that, but this time we would like to see, just to save time, I'm using the same title here. Control V. I've overwrite this, and this time this is something very interesting. ptr is a constant pointer to a constant integer. ptr always points to the same location. The integer at the location cannot be modified. अब this time what we have done, वो जो previous example में था, हमने इस particular example में, और the previous example which I have just deleted, there was just one single constant. But here we are using two constants. Means कि the data by itself, the variable that contains the data by itself is a constant, and the pointer is also a constant. So both are constants. The variable is also constant variable, and the pointer is also constant variable. When I try to modify this variable here, it does not allow me to do that. And when I try to modify this, actually I was trying to do in the previous example, that I am trying to loading the address of another variable into this pointer, and the same was also not allowed. So अगर हम इसी program को, if just let me compile it for you so that you can understand that. Now it should give me this error message. Expression must be modifiable, and this expression const pointer must be modifiable. So just to demonstrate the error message, so that अब देखिए बड़ा क्लियर मैसेज है. ptr this ptr, you cannot assign to a variable that is a constant. Similarly, you cannot assign to a variable that is a constant and this as value. You cannot do that. That's why ptr you cannot assign to a variable that is a constant, or here you cannot assign to a variable that is a constant. So this is a constant and this is a constant, and you have to be very careful when you are handling the pointers and the pointer constants, and when the pointer is pointing to a constant data or when the pointer is a pointer constant. Good. Let's move forward. We have done this example of the bubble sort, but today I would like to repeat this bubble sort. Instead of simple bubble sort that I have demonstrated, today I would like to use the pointers. So we will have a double revision. We will have the revision of the bubble sort, and similarly we can have a revision of the pointers also. Add new item. This is bubble sort with pointers. Okay, this is a bubble sort with pointers. So coming back, let's copy this. Hope that no unprintable characters makes our life miserable here. Copy. ये बाज़ का टाइम सेव करना हमें महंगा पड़ जाता है, because we get some unexpected errors here. Okay, first of all, just like to remove obvious errors. Space का void, bubble sort is okay. Unsigned integer, void bubble sort. Good. Array is undefined. Wow, where is array? Is undefined. What does it mean? Just to save time, I have quickly, instead of finding out the error, the easiest way is to write the array again. A array. Okay, so we have defined a of I, and then we say bubble sort a size, and then we call it here bubble sort integer const array. इसलिए it was undefined. Okay, अभी array ठीक हो गया. Yes, this seems to be okay now. Let us see. First of all, I'll like to explain it to you. In this example, putting the values into an array, sorting the value into the ascending order, and printing the result of an array. Or we have already done that before, but the difference is that this time we will be pass the value to an array as a constant value. Okay? And we are passing integer static const array, means the pointer is a constant. This array pointer is a constant. Data is not constant. The pointer is a constant. And size of t, don't worry, you just consider it's just like integer, but it has already been defined in stdio.h. Size of t means any integer which is we don't have basically the negative value. Okay, so here we have defined and initialized the array. For this is basically printing the array, value of array, just to show you the result here. this we call a bubble sort. Pass this array and the size to sort an array, and then the result, when you come back again in the main, then the result is displayed. This 4D means each data will be displayed in the 4 decimal places. This is just to have a new line, and here I would like to put system pause, and I would like to include IOStream. Okay, seems to be okay. Now coming back to this bubble sort function, I hope you remember that how this bubble sort performs. Okay, this is the bubble sort. It receives the data in array and receives the data here. Then it has defined a function that is only visible in the bubble sort because you have given a prototype here. और ये function जो है basically it is a swap. You know what is a swap. This swap function basically interchange the data. Okay, so it will receive the two elements, element 1 ptr, element 2 ptr, which is pointed to an integer, and this function should interchange that. Then there is a variable pass, and then this is the counter. Okay, so pass is equal to 0, pass is less than size minus 1, pass plus plus, and then is this one. मैंने आपसे बताया था you can optimize it by putting it just I would like to run it first, and later on I will optimize it. Then this one, and then if array of j is greater than array of j plus 1, okay, then we call this function swap, and we are passing this address of the array of these two elements. Okay, this is the address of the array, and since we are passing a subscript, so basically we are passing the address of the two elements to the swap function. Okay, this close the if statement, this close the inner for loop, and this close the outer for loop, and this close the bubble function, bubble sort function. So this is the function swap. This is a temp variable, integer hold, which basically just take the data of the element 1 pointer, and then you swap element 1 pointer because you have saved it here. So it is basically you copy this to this, and then this becomes empty, and then you can just copy it to this. So this is basically swapping. So we are doing this bubble sort with the help of basically pointers. Okay, so let us compile it. Control F7. Good, no error. Then we can just run it. Control F5. Pointed to an error.cpp. Okay, it's not compiling. Okay, it's compiling the same error code, so it's mean that we have not excluded this p pointed to error. We need to exclude that. Okay, p pointed to an error. Where is that? This is the function. Dear students, we have to be very careful. Now it will compile this one. इसमें तो line number 14 थी ही नहीं, and we were getting the error here. Okay, Control F7. Control F5. It works. Okay, so basically it was doing something because this particular file was open, and p pointer error जो हमने एक function बनाया था जिसको हमने exclude किया. Now this data 2648, this is the input data here, and we have passed on this data to the system, to the function, and here this bubble sort function has basically performed this sorting. But this time the data was passed as a pointer, and here this bubble sort function has received the array constant here, and then the swapping is also done with the help of these pointers. So I hope that we have done sufficient exercises on pointers, but if we still have time, so maybe like to spend few more. I would like to skip this array structure name. Okay, something very interesting. I've told you to find out the data type and their sizes, and that you can always do with the help of size of operators. So this time I will just be using this good example to demonstrate that how can we find out the size of the different variables. So for that purpose I will use the same, and before I make any mistake, so I will just this time exclude it, so that I should not make any mistake here, and then I can just simply copy this back to this resource file. And now I open up, add new item. So basically P size of data type. This is the exercise, size of data type. I can just copy it here. Okay, size of long, size of long double, and size of array here, size of pointer here. So we have been able to remove most trees, just one, and let me see, it is undefined. So it is undefined because there should be a space here. Okay, so I would like to put system pause, and here I would like to include string. Seems to be no error here. So what we have done here, we have created an array of 20 integers. We have defined different data types: character C, short s, integer I, long L, long LL, float F, double D, long double LD, integer array, and integer static PTR array. Now we have used this printf. It's a very comprehensive printer, but since the example has already been given in your book, so I have used the same. So it will print out with the help of this format specifier. These are the corresponding data that needs to be printed. So we can find that in our machine what is the default size of short, the size of integer, size of long, size of long, float, double, and that we can easily find out if we run this program. Undefined variable, these are all warnings. I'm not let me close down the previous one and then Control F7 once again. Good. And I hope that this is P size of data type, and then I say Control F5. And dear students, look at this. Size of C, which is character, 1 byte. Size of short is 2 byte. Size of int is 4 byte. Size of long is 4 byte. Size of long is 8 byte. Float is 4 byte. Double is 8 byte. Okay, and long double is 8 byte. Okay, these are the standard data types. In addition to that, just to save time, we have also defined an array here. This array contains 20 elements, and this is an integer array, and this is pointed to an array. So what we have asked the system to give us the size of the array and size of the pointer. So the system has given us the size of the array. Since each element should occupy basically the 4 bytes, and because this array that we have defined here, we have defined this array here. Okay, integer static array PTR. This is a 20 into 4 should be equal to 80 bytes. Okay, and the array, it contains 4 bytes. The pointer, since pointer is an address, so it contains basically the 4 bytes, and then we have this integer array of 20 bytes. So basically we have found the address size of the array, and we can find out the size of the pointer. Okay, so basically this array is basically, this is a pointer to an array, and this pointer to an array, and we have used here to find out the sizes of array and as well as the size of the pointer. But the important thing that I wanted to demonstrate to you is to find out the size of each data type that we have exercised and we have used in our example. Okay, still I have quite a few examples to demonstrate. Let me see, it is subscripts and pointers. So we define subscript and pointer. Once again, it has taken a lot of time to debug, so no mistake this time. Subscripts and pointers. This is the name of the file, and I can copy it. Control C, and I can just place it here. Okay, so in this particular example we will be demonstrating using subscripting and pointer notations with arrays. So I would like to print this particular array in 4 different ways. Number 1, I have declared this array B, which is creating and initializing an array. Then we can create a pointer, and we have loaded this integer static pointer is equal to B So we can do that simultaneously. We can initialize it and also we can load it, and we can do it in 2 steps also. We can define a pointer and later on we can just load the address of the pointer. But in this particular statement we have defined and loaded the address. So basically we have created a bptr, which is a pointer to an array, and it contains the address of array, which is array b that we have defined. Then we have defined some variables, counter variables, non-negative, and now we are printing this array one by one. First time we are printing the array by output array by using array subscript notation. ये जो आप standard use करते हैं, this is basically the subscript notation. Okay, don't confuse, this is just for the printout, and it will be printing b angle bracket, and whatever the data of I is, it will be printed here with the help of this %u, and then it will print the angle bracket also, just to show you that this type of output is for basically using the array with subscript notation. Then we can output array using the array name and a pointer offsets. Okay, here the output will be the array name, and that is basically we have used a b is a pointer notation, and we are using it, and plus we are using it as an offset. And what is offset? Offset is initially 0, so it is b plus 0, then b plus 1, b plus 2, and this time we are using the same array, but we are using it as a array name and a pointer offset. Third, we output an array by using pointer and array subscript. Okay, reverse hai. We are, instead of using the pointer, still we are using the pointer, but we are using in the notation of array. हम देखें कि bptr is basically a pointer. हम इस pointer को array की notations के अंदर use कर रहे हैं. bptr angle bracket as a subscript, but array कौन सी है? Array is b, and we are using it, instead of b we are using it a pointer, but still utilizing its representation in angle brackets. Fourth output, array b using pointer and pointer offset. Not only we are using a pointer, but also we are using a pointer offset also. So this time it is a pointer bptr plus the offset, pointer offset. पहले हमने use किया था यहाँ पर array का नाम and offset, pointer offset, and here pointer and pointer offset. So 4 different ways through which we would like to print out this particular array. So no output window is open. I hope that no other file open. So let us see, compile it. psubpointer.cpp is successful. Then control F5. Okay, same. We need to stay in order to see the output, and before the end of this particular loop we will put pause. And for that purpose I need to include iStream. Okay, control F7 to compile, control F5 to run, and देखिए the first subscript notation, इसमें हम array को as it is use कर रहे हैं, standard way that we have learned in the beginning. Then pointer notation, we are using the offset, and name of the array is being used, an address of the array but this time we are using it as a pointer. हम b को b++ नहीं कर सकते because name of the array is a pointer constant. लेकिन हम ये कर सकते हैं कि b को यूज करके बजाय इसको इंक्रीमेंट करने के +1 +1 +1 या प्लस करें या +1 इसमें ऐड करें +2 ऐड करें. What we can do is कि we can just use it as an expression. इस expression में b remains the same and this +0, now this becomes an expression and this becomes an address, और इस address को हम इस pointer की मदद से इसके contents pick कर सकते हैं. So this is the demonstration of notation where we are using the name of the array but as if it is a pointer. Then we are using a pointer but using it like this array. Here we are using the array with a subscript. The same array we are using here, but instead of b we are using its pointer, but still we can use it as a subscript. Finally, we are using here instead of b we are using a pointer and using the offsets. So the 4 different ways through which we can manipulate a particular array, that is whether we can use it directly, the name of the array as a pointer, or we may define a pointer that can manipulate your array. So copy string using array and pointers. Okay, students, I hope still you have some energy. So let me take few more examples. If you cannot do it in one sitting, you can do it in multiple sittings, okay, but let me do it in one sitting. But I advise you that you can go through this particular exercise, and in this particular okay, where it has gone somewhere. Let me see whether it comes back with Ctrl Z. Okay, so it is here. So I open a new environment, and this time I have the exercise which is copy string using array and pointers. So I can just do that. Copy string using array and pointers. So let me copy this exercise number 9. I can copy and then paste it here. Good. Just need to correct. This skips few spaces. Const char. Seems to be okay. So what we want to demonstrate here, copying a string using array notation and pointer notation. So we have defined here string 1, string 2, string 3 and string 4. String 1 is just the create an array string, which is an empty string. String 2 we have created it with the help of a pointer. String 3 is another array, and string 4 you can use it, although it is an array, but we can use it as a string 4 as name of the array as a pointer. So we have defined hello and goodbye. So we copy 1 string 2 into string 1, and then we can display printf using this. We can output. Then we can copy string 4 into string 3, and then we can also display the result. So this is copy 1, and we have given the prototype here for copy 1, which is basically character const s1. Okay, so s1 is a constant. You can put this constant before, or you can put the constant here. So we can say the character static const s1, and const character static const s2. So basically what we say here that s1 is a character constant and here the data is constant because the const character static const s2, but this is both, the data is constant as well as it's mean that this is a constant data and this is basically the const character. Okay, so what we can do, we can just try to copy it, and we see that we copy using pointer notation. So we are copying s2 into s1. S2, the data you cannot modify, but you can copy it into s1. Here we are doing it, we are copying it s2 one by one. For loop, we have not initialized it because it has already received the address. When you pass the argument, it receives the address in s2. So here we are using the address s1 and s2 has already been initialized. So we are copying character by character here until it is not equal to 0. Then s1 plus plus, then s2 plus plus. Since these s1 and s2 are the pointer variables, because we are using it here, so that we can do always this one. So we can copy it, and here we are copying s2 into s1 using this copy is like you are copying two variables in the array, and here you are copying the data as if they are pointers. So this basically is a very simple single concept that we want to demonstrate it in this particular example. Copying it as a array, copying it as a pointer. So let us see. Let me put a pause here so that I could see the output also. You could also see the output. What we can do, we can copy it also. Instead of copying, we can type it here. Okay, so IO stream मुझे type करना पड़ेगा. Include IO stream. That's it. It should work now. Control F7. Yes. Seems to be okay. Control F5. String 1 में we have copied hello, and string 3. Okay, so basically we have copied string 1 में we have copied hello using notation of the arrays, and here we have copied from this to this using a pointer. These are very simple exercises, but are very, very important to learn the concepts. So shuffling and card shuffling, maybe should I skip it or not, but let me see how many. One more example, students, please bear with me. I don't want to skip it because it contains a lot of concepts that I would like to demonstrate in one go. So this is the example given in your book. So just one more example, please. I think you should enjoy, instead of taking the pressure of this lot of demonstration, you should enjoy it. Take your time. You can complete all these exercises in different sessions as per your convenience. So this is basically exercise for the card shuffle. Okay, card shuffle. And I can just, although I wanted to skip it, but it contains very, very interesting exercise. So after completing this, then I will stop. Copy. Let me get rid of this unsigned integer wdeck. D unsigned integer wdec const char. Let me complete first and then we can see. Okay, I just show you the demonstration and would like to explain what we are doing in this particular example. Here we are using the example that is given in your book, where we have the cards that we need to shuffle. So this card we have defined suits 4, means we have 4 suits. That mean we have heart, diamond, club and spades, and then we have 13 faces. You know that there are 52 cards, 13 cards for each suit, so there are 52. So here this is a function which is that shuffles the data, and here this function is a D that you are going to distribute the card among the players. So here we have defined const characteristic suit. This is basically the for initialization, and here we have initialized 13 card of each face, and then with this particular function we initialize this array with 0. Initially there is nothing there in this particular array, and then this random number is generated because we have to randomly shuffle and distribute the cards. Then we call the function shuffle that shuffles the card, and then finally we call the D that the shuffle card should be distributed among the players. So here it ends, but before it ends I will like to put here system pause bracket close this. Okay, so then this shuffle programs, basically you see that the card points to each and every card that you are going to distribute, and you know the cards are basically 52. So basically you generate a random number and find out that while this card column is not equal to 0, you find out an empty place where you are going to put in the card. तो जब तक वो आपका empty place नहीं मिलेगा, you will randomly finding it out the card number, and that card number is row and columns like this. Okay, so once you find that particular place, then you can insert the card over there, and finally you can deal. And D is basically distribution of the card to row and column in both directions. Okay, so let us compile it. Finally it's successful. Let's run it. So we have another same problem. We have got some main left somewhere. This so I compile it again, shift F7. So this is basically the random distribution. 6 of heart, this is the for player 1 gets that, and this is the player 2 gets that. For example, if you have distributed it among 2 players. So basically I have just gone through this particular example very quickly in order to just show you that once you go through the details, you have studied each and every concept that has been utilized in this particular example. This is just a matter that how you spend the time and try to understand what this example is doing. Okay, so I leave it to you for this today's demonstration session, and I expect from you that you will go through with all the exercises that I have tried and demonstrated today. So I will come up with another demo session inshallah in the next lecture. Till then, Khuda Hafiz, Allah Nikeba.